Let's practice solving an application word problem dealing with a linear system. For this particular example, we're going to be dealing with a situation where we have two different purchases of two different items. Real quick before we get started, if you'd like to download a free copy of this PDF, you can find a link in the description box below, where you can also find an answer key PDF that is there as well in case you need it. Also, if you'd like to try this problem on your own first, feel free to pause the video now to give it a go. Otherwise, let's go through it together. So in this problem, a sports equipment store is having a sale on soccer balls. So a soccer coach is going to be going and purchasing 10 of these soccer balls, but they're also going to pick up 2 of these soccer ball bags for $155. A different soccer coach is going to be purchasing 12 soccer balls instead, but they're also going to be buying 3 of these soccer ball bags, but their total cost is going to end up being $189. What we're going to do here is we're going to find the cost of one of these soccer balls, just one of them. We also have to find the cost of just one of these soccer ball bags as well. First, before we do anything else, let's go ahead and define our variables. Let's go ahead and let the variable x represent the cost of one soccer ball, and let y represent the cost of one soccer bag. Now that we've defined what our variables represent, let's go ahead and see if we can write some linear equations. So let's go ahead and start by writing our first equation, which represents the purchase that the first soccer coach is making. So for the first soccer coach, they are buying 10 of these soccer balls, and remember, we don't know the cost of one of them. We said let's let x represent the cost of just one of them. So if we don't know the cost, we can say the expression of 10 times x, or 10x, would represent the total cost of these 10 soccer balls. But they also go ahead and buy some of these soccer ball bags, so they buy 2 of these bags, and again, we don't know the cost of them. We're saying y represents the total cost. So the expression of 2y is going to represent the total cost of the bags. Now, adding these two costs together, we also know the total that the soccer coach spent, which was $155. So adding up the total cost of the soccer balls and the soccer ball bags, we have a total of $155. So there we have one of our linear equations, but what about the other soccer coach? For the other soccer coach, let's go ahead and create a second equation for coach number 2. It looks like this second soccer coach is buying 12 of these soccer balls, and we don't know the cost still, so we're going to say the cost was x, so 12 times x, or 12x, would represent the total cost of the soccer balls for this coach, plus they buy some bags as well, so it looks like they're buying 3 of these soccer ball bags. So again, the cost of one of those bags is y dollars. So we're going to say the expression for that total cost is going to be 3 times y. We also know that this coach spent a total of $189, so let's go ahead and set this equal to and write 189 for the total cost for this coach. So here we have one of our linear equations that represents the total that this first soccer coach spends, and we have a second linear equation here for what the second soccer coach spent. Since we have 2 variables and 2 of these linear equations, let's use them together to figure out the cost of each of the soccer balls as well as each of the soccer ball bags. Let's go ahead and put these 2 equations together and solve them as a system. I guess the question is, do we want to try to eliminate the x terms, which we have to figure out when 10 and 12 meet for the first time. So I think 10 and 12 are going to meet probably at 60 for the first time. I think that's their LCM. Or we can figure out when the y coefficients meet for the first time. So 2 and 3, they seem to meet at 6. So totally up to you which one you want to eliminate. I think that getting to 6 would be a little bit easier here, or maybe a little smaller numbers. So I'm going to go ahead and eliminate the y terms. So let's focus on this 3 and 2, and we want to make their coefficients match, or at least be opposites here. So how does 2 become 6? Well, let's go ahead and multiply this whole top equation by 3. If we multiply that whole top equation by 3, 3 times 10x, that's going to be a total of 30x. Then 3 times 2y, that's going to be a total of 6y. And then 155 times 3 is going to be 465. For this equation below, how are we going to get 6y? Well, we already have 3y. Let's go ahead and multiply this whole bottom equation by 2. If we go ahead and multiply this whole bottom equation by 2, 2 times 12x is going to be 24x. Then 3y times 2 is going to be 6y. And then 189 multiplied by 2 is going to be 378. Now these equations are in perfect form for us to use our elimination method. Based on what we just did, we got these coefficients for the y terms to match, so we have 6 and 6. Now what's going to eliminate these y terms? I think it's going to be subtraction, right? Because 6y take away 6y would equal 0y. Okay, so let's go from left to right here. So we have 30x take away 24x. 30x minus 24x is going to equal 6x. Then we have this 6y take away 6y. Those are going to eliminate, so we can eliminate those y terms. And then on the right side, This 465 minus 378 is going to equal 87. Now for this one-step equation, let's go ahead and divide both sides by 6 here. And when we divide 87 by 6, we should find out that's equal to 14.5. So we found out that x is equal to 14.5, which is basically saying that one soccer ball costs $14.50. Let's go ahead and use that information to figure out the cost of one of the soccer ball bags. We can do this by substituting this 14.5 in for x for either this top equation here or for that bottom equation down here, totally your choice. I'm going to go with substituting it into the top equation. Okay, so substituting this into the top equation here, we're going to have 10. We're going to multiply that by the 14.5 that we just found out for the value of x. We're substituting that in. Then we have plus 2y, and this is going to equal 155. Multiplying 10 times this 14.5, that's going to equal 145. So it's 145 plus this 2y, and that's equal 155. All right, so we have a two-step equation here. To solve this, let's start by subtracting 145 from both sides of the equation. And when we do that, we're going to be left with 2y on the left side of the equation, and 155 minus 145 on the right side is equal to 10. One final step, let's go ahead and divide both sides of the equation by 2 here, and we find out that y is equal to 5. This basically tells us that we know the cost of one soccer ball bag is $5. Putting these two pieces of information together, we know x is 14.5 and y is equal to 5. So if we were to graph these two linear equations, they would intersect over in quadrant 1 at 14.5, 5. While these are the solutions that we found out from all the algebra, what does this actually represent in the context of this problem? From the solution, we can conclude that the cost of one soccer ball is $14.50, while the cost of one soccer ball bag is $5. Of course, these prices could change if you go to a different sports equipment store, but this is what these prices would be for this particular store. So that wraps up this video on this practice problem dealing with this system of linear equations, where we're dealing with purchasing two items, knowing their total cost for each of these transactions. If you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.